Nice to see you again. We're on to the next lesson of the DIY Gamer. So, quick recap, we've managed to draw a ship to the screen and we've been able to move it around, left, right, up and down. It's constraining itself so it doesn't actually draw outside of the boundaries of the screen. Fantastic. So there's a couple of things missing now. Obviously, we now don't have any real game mechanics around how the game is played. So what we're going to start kind of working towards is doing things like drawing the walls into the game and checking for collisions. And of course, then deciding whether or not the game is over, maybe a point system. Before we jump into that, that becomes slightly more complex. And so what we need to do is start giving ourselves some tools that'll allow us to basically help to debug what does work or doesn't work inside of our code. So one of the most useful and brilliant ways to debug your code and to understand what the program is actually doing is this idea of creating a serial communication connection. So a serial connection is basically, you've got this USB cable. This wonderful USB cable goes from your computer straight into your gamer. That USB cable is what's used to program the gamer. But the other cool thing is that you can actually get the gamer to talk back to you via the USB cable straight into your Arduino software. So in order to do that, we have to set it up inside of our setup. We have to tell the gamer that we want to use serial. And we have to tell the serial how fast to communicate. We're going to use a speed of 9600. The reason why I know that the speed exists is I have checked the reference to find out what the different speeds are. One way to find the reference is you click on Help and you click on Reference. And here is the reference library. I'll make it slightly smaller. There it is. This reference is fantastic. It tells you everything about the stuff that we've already been programming with inside of the code, all the structure of the code, the way that you define data types, integers are mentioned and explained over here. What is an if statement? What is an if-else statement? These are all really useful explanations for how we are going to be programming additional complexity into our games. So what do we want to check? We wanted to check for something called serial. So I'm going to search for serial. There it is. Click on serial. So the serial reference is extremely helpful. It explains in a lot of detail how to use the serial connection between your Arduino and your computer. It even tells us that it's used for communication between the Arduino board and a computer or other devices. And all Arduino boards are able to communicate over serial. So there's a couple of great examples down here which you can use to try to understand how serial works and ways to use the serial on your Arduino. But in our case, I am going to click on the .begin function. So if I click on begin, it explains that it sets up the Arduino and it sets the data rate in bits per second, or baud, okay? B-A-U-D. Now, you'll see these are the set rates, 300, 1200, 2400, 4800, 9600. Obviously, the higher the number, the faster it communicates. We're using something that's kind of on the lower end, which is 9600 bits per second. So I know that 9600 I wrote in my code was correct. Let's go back to our code. Here it is. Serial.begin 9600. So set up our serial connection using 9600 bits per second data rate, okay? Speed. Great. Now, how do we actually use the serial connection? Well, the immediate thing I'm going to do is I'm going to use another function, which is the printLine function. Again, how do I know that there's a function called printLine? Well, if I go back to my reference, let's have a look here. Oh, look, down below our examples, it even mentions printLine down here. So we're going to just keep looking at the bottom of the reference. It says the other things that you might want to look at after looking at the begin function, and it suggests down here print and printLine. Let's click on that. PrintLine function prints data to the serial port as human readable ASCII text. Basically, that means it prints stuff that you can read. So the way you use it is you say serial.println and then whatever the value is. So in our case, I'm going to say serial.println started. Let's upload that and let's see what it looks like. Okay, it's finished uploading. Nothing changes, the code still does what it does. How do we know that the serial connection is working? Well, we have to open this thing called the serial monitor, which you'll find on the top right hand corner of your Arduino software. And when I click on it, oh look at that, something comes up that doesn't make any sense at all. Lots of squares and a weird ST. That's very strange. Now the reason for that is because the serial monitor has to be told what speed it has to be communicating over serial. Because remember, we set up in the Arduino code that we're using the 9600 bits per second. So if you look in the bottom right hand corner of the serial monitor, you'll see this little drop down, drop up options section, and that's your bits per second, and we're going to choose 9600. And as soon as I do that, it resets the Arduino. There it is, it says started. So now we know that the setup is complete. That's really cool, but it only happens once, obviously, because that's in the setup. So if we go back to our Arduino code, so let's make something a bit more useful out of that serial monitor. Let's say, for the sake of argument, I would like to see how many points I'm scoring, or see how many times my spaceship has drawn to screen. So I'm going to create a variable, call it point count. I'm going to set it equal to 0 at the beginning. And then what I'm going to do is, inside of my loop, I'm going to say point count is equal to point count plus 1. Yep. And then I'm going to say serial.println point count. So you see, I didn't put inverted commas this time because I don't want to have the string that's point count written to me via the serial. What I'd like it to do is actually send me the value point count. So I'm not putting inverted commas in. Look what happens to the code if I put the inverted commas in. It goes a different color because it's saying that it's going to print that out as text as opposed to the variable itself. So let's upload that and let's see what it does. Again, hopefully we'll see no changes to the screen, but what we will start to see is something printed on the serial monitor. So as I click on the serial monitor, there it is. It's telling me how many times it's drawn the Arduino, the spaceship to the screen. Okay, that's great. Wow, it's already on 900. That's a lot of progress. We're winning here, man. We're winning. But of course, we haven't created the mechanics to prevent us from ever winning forever. Let me start again. But we haven't created the game mechanics yet that will ever help us lose. So I guess we'll just win forever. Let's say we want to give ourselves something a little bit more useful as information about that value I've just printed. So remember, I just said we're printing the variable value, not the name of the variable. What happens if we want to print the name of the variable and the variable value so that when we're reading it, it makes a lot more sense to us? What we would do is use a slightly different function on serial, which is the print function. Our print, what it does is it prints whatever you tell it to, and then it stops there. And then if you print something else, it'll carry on from where it left off. And if you print something else, it carries on from where you left off. So essentially, it's like it leaves the position of the last print in that same position. What println does, println, is that it says, well, once you've printed that thing that you've asked for, then go to the next line. It's like pushing the enter key or the return key on your keyboard. So let's see. If I say serial print, now I'm going to put in inverted commas because I wanted to actually I wanted to myself point count is equal to, and because it's the print statement, it's only going to go print out point count equals and then wait there, and then on the next line, the next command, it's serial.println point count the variable. So then it'll go the variable and then go to the next line. So let's see if that does what we said it will do. Upload, upload, upload. Okay, look at that. Ooh, it's busy flickering. I'll explain that to you in a second. Let's go to our serial. Oh, look at that. It's explaining to us exactly what I said it would do. It's saying point count is equal to the value, and then it goes to the next line. Now, do you notice all this flickering? Yeah, you probably do see this flickering. The reason why that's flickering is because the time it takes for the Arduino to send information over the USB into the computer seems to be quite long, because it seems to be slowing down the drawing back to the screen. It clears the screen. Let's look at our code for a second. So look at this. In the code, we have the gamer clear function, and then we increase our variable, and then we print stuff out, and then we do all the drawing to the screen. Interesting. So it stays clear the whole time until that moment. So what I'm going to do instead is I'm going to cut that and put it above the clear function, and let's see if that fixed the flicker. It's all about the positioning of the things that you do inside of your code that can have a huge impact on what the outcome is. So look at that. Much more solid. And is it still printing to the screen? Yes, it is. Look at that. Brilliant. So, that's all very good news. Another thing you could do to prevent the flicker is actually to speed up the serial. So we use 9600 bits per second. You could go all the way up to 115200, which is the fastest that this can communicate. I'm going to upload that now. It'll be much, much faster. But remember, when you open up the serial monitor, you have to change the board. Look at that. It's coming up as total crazy characters. Click on that, choose 115200, and look at it go. Boom. Printing beautifully. Very, very happy. So I'm going to close that down. So we now understand how serial communication works. Another thing that I can do, for example, is I'm going to take out the point count for a second from everywhere in the code. And now what I'm going to do is just to understand where my ship position is, because I want to be able to think about what to do with those values. I'm going to say serial.print ship x is equal to, see, I add the spaces in there as well. And then I'm going to say serial.print ship x. And then I'm going to just copy and paste both of those and say serial.print. Now I'm putting a space after the last value that was printed, which was the ship x variable. So I put a space after that and say ship y is equal to, and then at the end I'm going to say ship y. And of course the last one I'm going to add the ln to the end of the print, so it goes to the next line. And let's see what that does now. So this is going to tell us the x and y position as we move around the screen. Let's have a look. There it goes. See, as I changed the position, there it is. It's on the bottom, so it must be ship y is equal to 7. Let's move it over to the left. It's at ship x equals 0. Let's move it up as high as we can. Look, ship y won't go above 1. Why? Because it's constraining it. The ship x and y, remember, is that bottom left-hand corner of the ship. So this is good. It's proving exactly what we thought would be happening while we were busy programming it before. Brilliant. So now that you've seen this thing called serial communication in action, hopefully you can start to understand how useful this is to help you to understand what's going on inside of the code. And when things break, you can then give yourself messages that will help you to understand how to fix them. So this is really the beginning process of your awesome debugging techniques. So thank you very much for joining me on this DIY gamer lesson. Join me in the next episode for something perhaps a little more game mechanic oriented, maybe some wars.